Cumulative frequency tables and graphs. A cumulative frequency table displays a running total of the number of times, or the frequencies, that data items appear in a given interval. A cumulative frequency table is very similar to a regular frequency table from last topic, with the difference being that the cumulative frequency represents the total number of data, not just from the current row, but from all the rows prior. A cumulative frequency table is shown with the time intervals in the first column, tally in the second, and the cumulative frequency in the third. A cumulative frequency graph displays the data from the cumulative frequency table. It is drawn by plotting the cumulative frequency with respect to the upper bound of each grouping, or in our case, time period. The upper bounds for the table below are 20, 30, 40, 50, 60, and 70. The cumulative frequency is plotted on the vertical axis, while the time is plotted on the horizontal axis. A cumulative frequency graph can also be used to estimate the median of a dataset. The steps are provided below. First, find the middle of the cumulative frequency range. In the graph below, this value is half of 16, or 8. Draw a horizontal line from this value to the graph. Draw a vertical line from the graph to the x-axis. The value found at the x-axis is the approximate median. In this example, it is very close to 40. Below is a tally for test scores. Determine the cumulative frequencies to complete the table and construct a cumulative frequency graph for the data. All right, so we start with a tally of 1, then we're going to add 0 to it, so it's still 1. Add 0, it's still 1. Add 1, we have 2. Add 4, we have 6. Add 5, 6, 7, 8, we have 14. And then 15, 16, 17, 18. So therefore, at 100, we will have 18. At 90, we will have 14. At 80, we will have 6. At 70, we will have 2. At 60, we will have 1. At 50, we will have 1. And at 40, we will have 1. All right, and here's the graph. We can see that we start at 0 at the 30. Use the cumulative frequency graph to estimate the median of the dataset. All right, so 18 is the highest point, so we go to 9. We go across and we draw a dot here, and we go down and we see that's just there, like around 84. And here you can see our blue lines across and then down, and they say that it's about 85. Yep, there it is. Below is a tally for test scores. Determine the cumulative frequencies to complete the table and construct a cumulative frequency graph for the data. All right, so we start with 0, we add 2. Then we add 3, giving us 5. Then we add 2 more, 7, add 1, 8. We're going to add 5, which is 13, 14, 15, 16, 17. Okay, so for 100, we have 17. There. Okay, and then for 90, we have 15. For 80, we have 8. I'm kind of going backwards, but I like going backwards. All right, 70, we have 7. 60, we have 5. And then 50, we have 2. And then for 40, we will start at 0. So it looks like this, like that. And here you see the answer, this graph right there. Use the cumulative frequency graph to estimate the median of the dataset. All right, the highest point is 17, so we have to cut that in half. 16 cut in half would be 8. And 9 doubled would be 18. So we're looking at 8.5 as our the frequency that's in the middle. If we go across, see that it's right here. It's like a little bit more than 80 is our median. As you can see here, the median is about 82.